heaters for a very, very long time. Bosch actually has a patent which is dated 1896 for tankless water heaters. So today we're going to talk about the lineup. What is the T9000 series? Features and benefits both for the end user and for the installer. We're going to talk about the combustion technology, and combustion technology is very important for this product. We talk not only about efficiency, thermal efficiency, but we talk about efficiency, combustion efficiency. How well does the unit burn gas? Recirculation for domestic recirculation, the different ways that we can accommodate that. Installation accessories, things like our venting, how's that going to work? What do the controls look like? And just very briefly, what the controls look like. We are planning another seminar which will actually specifically address just the controls on the unit. Those controls are driven through the HMI, the human machine interface. That's how we navigate through the unit. Component details, what is actually inside the box makes it work, some application stuff, and then we'll wrap up with your questions. This presentation, seriously, this does not replace the installation operations manual. Every unit comes with it. Make sure you review that. Make sure you read and understand that installation operations manual before you launch into an installation. If you do have questions before acquiring a unit and you want them answered, Bosch Heating and Cooling is our website. At boschheatingandcooling.com, you can download the installation manuals, applications manuals, as well as engineering submittal sheets. All that kind of stuff is available there. No sign up, nothing like that, no passwords, and you can download all of those as PDFs. If you're in the field and you're stuck on something and you need some help, you can use our tech support line. Tech support line, great group of guys up in New Hampshire. They're very ready to help you solve your problems. You are going to need to be in front of the unit because they want to help you solve the problem right now. So when you're in front of the unit, give them a call and they can help you out if you got any points that you're stuck on. So with that, we talk about Bosch Thermotechnologies. That's the division of Bosch that I work for, Bosch Thermotechnologies. Bosch Thermotechnologies, as we said, has been doing dedicated domestic water heating, tankless water heating for well over 100 years at this point, since 1896. So we have our classic range of products. We have our new range of products, the T9000 that we're talking about today. Bosch also does boilers under two brand names. Bosch does boilers under the Budaris brand name, and we also do boilers under the Bosch brand name. That's our Greenstar condensing, modulating condensing, floor standing boiler. And we do heat pumps. We do heat pumps as water source or geothermal. We do those commercially under the Florida Heat Pump brand name, residentially under the Bosch brand name, and also under the Bosch brand name, we have our air source heat pumps, our gas-fired furnaces as well. So we really have a complete range of home comfort products. Specifically in Bosch Thermotechnologies domestic water heating, we also have our range of electric heaters. The electric heaters include our Greentherm9000T, which is a mini tank series, 120 volt, 1440 watt elements, available in nominal sizes of 2.5, 4, and 8 gallon. The 2.5 and the 4 actually have pigtails attached, so those products simply plug into the wall, no hard wiring involved. And we talk about the Greentherm9000 point of use, so this is going to be an on-demand tank or on-demand electric point of use water heater, low activated and available from 3.4 kilowatts up to 12 kilowatts. And then the Greentherm6000C range, which includes the WH17 and WH27, which are respectively 80 amp service and 100 service for whole house features. This is what we really want to talk about. We want to talk about the 9000 series, and we call it the 9000 series because it is a range of 7 distinctly different models, different features and benefits. They're all built about the same chassis.
Excuse me, Chaz. I'm so sorry to interrupt you. We are facing, our audio is fading, like fading in and out, and I see some people are with the same situation. Can I ask you please to disconnect and connect again? Let's see if it's going to work.
Disconnect the presentation or disconnect my microphone?
Yeah, you like leave the meeting and then you join again.
Okay.
Because I'm not sure if it's the internet connection or if it's just this temporary issue.
Okay.
I'm so sorry.
No worries. I will drop out and jump back in a second.
Okay, and for the participants, I'm sorry about that. We are with a storm here in New England today. Chaz actually is in Delaware, but I don't know how the weather is there. Thank you so much for your patience. And let's wait. Chaz will be back soon, and I hope you is a better audio. I am receiving some message that my audio is going in and out as well. Um, I will dial in on my phone, but most important now is fix Chaz audio. Chaz, are you back? Hey, Chaz,
Sure.
can you hear us? Can you hear me?
I hear you, Elaine. You don't hear me.
Okay. Yeah, so let's try again, and I hope the audio is better. They are saying that my audio is fading as well, but I told them that you, your connection is much important than mine. I will dial in using my phone, but please go ahead. And I am so sorry to interrupt you during your presentation.
No, well, if it's not going well, it's got to be interrupted, unfortunately. Hopefully this is better. Using my same headset I use, I'm not doing anything different. So hopefully we're all good here.
Okay, thank you.
All righty. So the Greentherm9000 series. We created the Greentherm9000 series out of a lot of research. This product range was built specifically for the North American market. This is not an adapted product from somewhere else in the world. It was designed specifically for the North American market. Previous range of products that Bosch had in the marketplace was on the line or our lineup for nearly a decade. It had truly fallen out of the state-of-the-art position as far as for its technology. In 10 years, controls change a lot, technology changes a lot. We needed to put ourselves back in the state-of-the-art position. And our previous range was the first condensing tankless water heater here in the United States, so it was a state-of-the-art product. That more importantly, we want to put ourselves truly in a benchmark position, a benchmark to say that we have the product that is the most functional. Particularly, we're talking about most functional for the installer in the field for ease of installation and in order to most easily do a tank retrofit situation. And also very importantly, we have to make the consumer happy, and the consumer has to be comfortable with very, very stable temperatures, very, very fast response time. All of those things are very important as we talk about tankless water heaters. Models are the T9900s and the T9800s. All of these products are field convertible. In fact, you cannot buy an LP version. You can only buy the natural gas version and then field convert it. The field conversion process, very easy. That field conversion process takes about 10 minutes total time. All of the controls in this unit are managed by OptiFlow. OptiFlow is our combustion management system. A combustion management system drives the efficiency, the response time, and all of the capabilities that are presented by the Bosch 9000 series. The base model for the 9000 series is the Greentherm 9800 SE from T9800 SE 160. It's the very base model. It is designed for residential applications. We can do other stuff with it, but the design or the intended design is residential applications. It does have a touch screen. It atmospherically adapts itself or adapts itself to the atmospheric conditions, current atmospheric conditions. Has the ability to do Wi-Fi if we want. We can actually install an optional Wi-Fi module, and then this unit can communicate with Wi-Fi phones or tablets. Room sealed is the design, so we're talking about bringing fresh air from the outside for the combustion process with extremely high efficiency. And the 160 on this model designates it as a 160,000 BTU maximum inlet unit. In the same cabinet and looks almost identical to it, the Big Brother. Big Brother is the T9800 SE 199 and 199,000 BTUs. Looks like this on the outside. We see some of the things that as we talk about the idea of being easier for tank replacement, the water connections are at the top of this unit. Flush connections are on the bottom. So we know a lot of the times that there is the issue with needing to descale a tankless water heater, and we add the clean out kits or the boiler drain kits. This is built into the unit. Touchscreen, so there's no buttons to lose, knobs to break, or anything to get lost. It is a touch screen. It is a tempered glass touch screen. It is very durable. can run this thing on a 1/2-inch gas line. We'll go through what the caveats are to that, what we have to have in order to run this off of the 1/2-inch gas line, but we can run this off of a 1/2-inch gas line. And we can also use it to drive an external domestic recirculation pump. Driving the external domestic recirculation pump allows the unit to control the flow of water for domestic recirculation. UEF up to 0.96, and as an advantage for the contractor, ease of installation in the field. On 2-inch PVC, solid non-foam core PVC, we can push the exhaust up to 60 feet. If we cannot get the exhaust out in 60 feet equivalency, we can step it up to 3-inch, same materials, and then we can go up to 280 feet equivalency. Flexible polypropylene is also approved, which makes it very nice for some retrofit situations. So that's 2 units. Then we go to the Greentherm9000 SEO. The O designates it as an outdoor unit. The 160 designates as 160,000 BTU input. Big difference here is that this does not have the touchscreen because the control is inside the cabinet. So it does not have a touchscreen. It has a mechanical type screen. And then there's the 160 or the 199 for the T9800 SEO, the outdoor version. And it looks like this. The vent for this outdoor unit is actually this channel around the Bosch logo here. That's the vent all the way around there. And the air intake is on the back of the cabinet, a series of louvers on the back of the cabinet. All the connections are on the bottom, including the water. Obviously, with an outdoor unit, you really don't want top connections. So we do recommend with this product that you do install those isolation valve kits. The isolation valve kits, the boiler drain kits, so we can descale this thing in place. The control, which is inside, can be attached with a wire and brought indoors, or there's also available an optional touchscreen remote, which gives all the same touchscreen capabilities as the indoor unit that can be added to this unit. 1/2-inch gas line, same thing. Field convertible, same thing. Then we go from the 9800 series to the 9900s. The 9900 Greentherm9000 SE160 looks like it's got all the same kind of features as the 98s, but what this does is adds built-in domestic recirculation. So now it's not going to drive an external circulator. The circulator is inside the cabinet, and the unit's ready to go for domestic recirculation. Also available 160 or 199,000 BTUs. So that's 6 different models. And then the capstone model, we'll get to in a second here. So as you can see, the 9900 looks almost exactly like the 9800. There's no additional porting, so there's no return port for domestic recirculation. The domestic recirculation returns to the cold water inlet of the unit, so there's no additional connections to make. And as far as for that domestic recirculation, it doesn't matter whether that's coming back on a dedicated line or whether that's coming back on the cold water line with a crossover. Either way will work. Capabilities for production of hot water, all the same, the difference being that built-in ability to run domestic recirculation. Then the capstone, the T9900i. The T9900i includes 9900, says it's going to have the built-in recirculation. It also has a very, very attractive glass cover, and the Wi-Fi connectivity is included with this product. So it has the Wi-Fi module and is ready to go for Wi-Fi as it gets out of the box. And this one will be available only at 199,000 BTUs. There's no 160,000 BTU version of this product. So that's the 7 units that make up the Greentherm9000 series. You can see here the 9900 does have that smooth glass cover. There's no bezel ring or anything around the HMI, that human machine interface. It's all smooth glass all the way across the front. Includes the Wi-Fi connectivity and built-in recirculation. Aside from that, its ability to produce hot water is the same as the rest of the range of products at 199,000 BTUs. So ultimately, who has to be happy with this product is the end user. The end user has to be comfortable. So we give very, very high flow rates due to the efficiency. Very, very stable temperature. We're using what we call an active bypass as part of our controls, which gives us very, very good control over our temperature stability. Activation flow rate at 0.45, so 0.45 gallons per minute flows through the unit. The burner is light. Then that can be turned down to a flow of 0.35 after the burner is light. The HMI, that human machine interface, will display in 7 different languages. Most importantly, I think for the North American market, most commonly we have the English, Spanish, and French. We will also display in German, because Bosch is a German company. It displays in Portuguese, our factory's in Portugal. It also displays Italian, and the last language that it displays is actually Chinese. High efficiency, fully condensing. Modulation, and although the consumer doesn't necessarily understand what we mean when we talk about burner modulation, we know that that 22-to-1 turn down ratio is huge in allowing us to be very, very stable in temperature. The burner is segmented, so that's a new thing for Bosch to do. Historically, we've always used just fully induced burners. We do now have a segmented burner. Very low pressure drop, and when we talk about pressure drop, we can talk about the pressure drop through the heat exchangers themselves, how much water pressure drop is there on this unit. But we also find it's very important to talk about pressure drop through the combustion chain and how hard does the fan have to work to push the exhaust. So we actually have a very low pressure drop there, which is what allows us to go out to that 60-foot equivalency on 2-inch PVCs. Some performance stuff here, so we can talk about pretty much the worst case in North America that we would need to get to 120 degrees, and 120 degrees is a fairly common setting for a tankless water heater. These do come from the factory locked at 120 degrees. The contractor in the field with a passcode can unlock that and take the temperature up to a maximum of 140 degrees. So we're talking about a 75-degree temperature rise. That's telling us that we have water coming in at 45 degrees and it'll leaving the unit, the set point is at 120. And we see that we can get 5.25 gallons per minute out of the 199,000 BTUs, 4.25 out of the 160,000 BTU unit. And then we got this little flag up here in the upper right-hand corner, and probably some of your eyes are rolling back in your head going, nothing is greater than 99% efficient. It just can't happen. And if it does, it's under special circumstances of a certain precise flow rate and a certain precise temperature rise and all those kind of things. Anecdotally, I have seen at this point hundreds of these units in the field over dozens and dozens of different locations, and consistently, in my mind, how even without an analyzer or anything, you can be certain that these things are that efficient is I can tell you the temperature of the stack, the exhaust temperature at any installation without even having the unit installed. Consistently, stack temperature never goes more than 25 degrees above incoming water temperature. So again, in this situation here, if we had 45-degree water coming in, our exhaust will be 70 degrees coming out of this water heater. And that's going to be at a maximum. More typically, they operate with that stack temperature about 10 or 15 degrees above incoming water temperature. So extremely, extremely efficient product. And all of that is managed for us by OptiFlow. That is the logic on our board that drives everything that happens. And it gives us automatic combustion adjustment. So this is where it's going to modulate all that happens inside of the unit based on atmosphere and all of that kind of stuff. Altitude adjustment is managed on board. On board is a barometric sensor. That barometric sensor allows the unit to be installed up to 8,500 feet of elevation with no adjustment from the contractor whatsoever. It automatically sets itself up for that elevation. There is, in converting it, we are going to put in a set of orifices, and then through the HMI, through the display, tell the OptiFlow that it is now an LP unit. Beyond that, the unit is able to set itself up for LP. We do not need a flue gas analyzer in order to convert this to LP. And then automatic vent configuration, the startup procedure for this, the first time it's powered up, or actually anytime it loses power, if the home loses power, it goes through an initialization process where it actually evaluates the load on the fan. The fan is driven by an ECM, so it's a true variable speed fan, and it looks at that load, how much work is that fan doing, and in doing that, it allows it to calculate its own developed vent length. So OptiFlow, we talk about automatic tuning. So typically when we talk about setting up burners on a modulating burner, we want to set those up with a combustion gas analyzer, a flue gas analyzer, in part because we want to make sure that our carbon monoxide levels are low so that it's safe, but more important, so that we hit that perfect stoichiometry. And we're going to do that by measuring this percent CO2 in the flue gas. One of the things that makes it sometimes difficult in doing that is if your CO is fairly high. You can see that the CO can be high, whether we're over here at low CO2 or whether we're over here at high CO2. So how does this unit do this without a combustion analyzer? Interestingly, the ionization current, so that's the current that we see through the flame sensor, the rectification current through the flame sensor, also moves in the same fashion as the percent CO2. So we use this ionization current to set up the unit or to allow the unit to set itself up for the installation where it is, as far as for the gas and air quality and all that kind of stuff that's coming into that unit, vent length, and all of those things are taken into account. It sets itself up for that with the ionization current. So it actually monitors what that current is through the flame sensors. So over here we got our lean mixture, over here we have a rich mixture, and where do we want to sit? Right here in the middle with that stable, efficient combustion. And this OptiFlow makes sure on startup that we set that up that way. It's going to optimize the combustion efficiency. So we can always talk about thermal efficiency. That's optimizing combustion efficiency. And then as we talk about why do we want the unit to control domestic recirculation? Well, we want the unit to control domestic recirculation because of that relationship between the inlet temperature of the water and the flue gas temperature. So as the water starts to come back to the unit hot, if we add, between that 15 and 25 degrees onto that, then our stack temperatures can rise to dangerous levels or potentially dangerous levels on PVC. So we're going to allow the unit to manage that. And when we say manage it, it is actually a scheduler by day of week. We can schedule by day of week, time of the day that we want the domestic recirculation on, and time of the day when we don't need domestic recirculation. So the behavior then for the unit is this. We got this period set up here for recirculation that's going to start at 6 in the morning and end at 9:30 in the morning. 6 o'clock in the morning, and this is whether it's on onboard pump or an external pump. Either way, it doesn't matter. The unit powers the pump. It's going to energize the pump. It's going to act as a switch for the external pump and actually power the internal pump. Circulator comes on, it's pushing water around the loop. The water's coming back to the unit. When that water comes back to the unit within 10 degrees of set point, the logic on the board then is to power down that circulator, shut that circulator off. Then what it does, for every 15 minutes out until 9:30, it's going to bring that circulator on and run that test again and run that circulator until the water comes back within 10 degrees of set point. That is adjustable to as low as 5 degrees or as much as 20 degrees. That is adjustable for different levels of comfort, so we can do that. Why do we want to do that? Two things. One, it's better energy efficiency. We really don't need the unit running nonstop to keep that domestic loop hot, so we don't need that. So efficiency is one part of it, saving energy, which is one of the biggest reasons why people want tankless water heaters. The other reason we want to do it is just for longevity of the unit. If we sat and let it run for 3.5 hours every morning, 365 days a year, that's a lot of additional wear on the unit and drives down the durability of the unit. So we want to make sure we're maintaining that durability. Easy minimum is an interesting function for you folks who might live in warm water areas. What it allows the unit to do is effectively set itself up in a short cycling, in a managed short cycling, in order to maintain temperature at very, very low flow rates with very warm inlet water temperature. And all of that is using this thing we call our active bypass. So in that idea of that it's a pulsating or short cycling burner, it's overheating the heat exchanger. And then overheating the heat exchanger drops the burner out. So the water flow looks like this. We have our cold coming in. Again, it comes in from the top on the indoor units, comes down to a T. At that T, it goes up through the water valve. So that's the primary water valve. That's one that senses the flow. There's an NTC thermistor here watching the temperature of the water coming in. Then it runs over here to this valve. Cold water comes in, goes through the heat exchangers, comes out of the heat exchangers, and it'll be overshooting set point a little bit. We're measuring that overshoot again with another NTC thermistor that sits right here on the outlet of the heat exchanger. It sits in there in a well and looks at that temperature. The response of OptiFlow then is to open this bypass valve, which then acts as an injector. It is not a true mixing valve. It's actually injecting cold water into that hot water stream to then manage that allowed overshoot back to set point. And we're confirming all of that with another NTC thermistor here watching the temperature as the water is actually leaving the cabinet. So that's what active bypass does for us. It maintains the temperature or ensures temperature stability. So what do you do to make the job easier for the guy with the wrenches, the guy getting out of the truck and installing this thing? BTU range with all very similar installation characteristics. Performance can be different by BTU, but installation is going to be the same. It has a relief valve included. Easy retrofit of tanks with the top connections. Yes, we can attach it to a 1/2-inch gas line, assuming there's enough gas pressure to manage that. The combustion management system says we do not need a combustion analyzer. The unit can manage that for us. We can use this thing in tank loading applications, domestic recirculation, and the maintenance is a lot easier with the bottom built-in ports for descaling. What are those external connections look like? So this is the top of the unit. We have our exhaust. It's a 2-inch exhaust. So we're going to take our PVC. We're going to cut it square. We're going to deburr it. We're going to push it into the stop. It is internally gasketed, so it's going to gasket around the outside diameter of the or outside circumference of the PVC. It's gasketed, and then we have the gear clamp here. That gear clamp is going to clamp that PVC in place. Same exact configuration on the air intake side. On the water intake, we have an inlet filter, so it's a built-in Y strainer type configuration, a basket strainer that's going to catch debris, anything that comes off of older piping or older city water or a well situation is going to grab that debris. And then the water connection is 3/4-inch male NPT, pretty standard there, and the same thing with hot water out. Then we have the port for the included relief valve on the indoor units. The bottom looks like this. We have our flush ports, and those are garden hose thread, 3/4-inch garden hose thread. So if you're using washing machine connectors to connect to your flush pump, your pony pump, whatever it is, then very easy to connect there. Same thing on both sides. Those flush ports have their own built-in valves. Those are those knobs on the ends. You can see on the end of the stub here. That's where the that valve is. We're going to turn that to open the flush ports. Condensate drain. Condensate is managed by a condensate collector, which is a siphon. So it's going to fill that siphon and then dump it periodically. It's not a constant drip of condensate. And in that, there is a breather hole external of the cabinet. So when we're connecting to that, we don't want to get some pipe dope in the breather hole. We don't want to get tape around it. We just need to catch a couple of threads with our PVC onto that connector. Gas connection, it is 3/4 of an inch. Yes, we can connect a 1/2-inch gas line, assuming again the gas pressure is adequate. And then also external of the cabinet, this stub right here is actually the nipple for your manometer for checking gas pressure. That sits right there on that external stub. Cover screws lock the cover in place, and it's held in place functionally with these spring clips. These spring clips are what hold it in place functionally. Knockout plugs, if we're going to connect to an external circulator, connect to an adjacent unit for cascading controls or those kind of things, those plugs are right there inside the cabinet ready to go. A little bit better view here of what that flush port looks like. And these do plug in. There's a pigtail attached. It's roughly about a 6-foot cord with, again, this external control for a wired. If somebody wants to have a wired remote, we have that external control wire there. Outdoor unit, we see, yes, 3/4 inlet, 3/4 out. Same cover screw configuration, same condensate configuration, gas line, and knockout plugs on the outdoor unit. Also the same inlet filter screen on the outdoor. Again, so this is the face of the outdoor unit. The vent is this channel around the Bosch logo. That's where the exhaust is coming out. And the back side is where we're pulling the fresh air in through a series of louvers. Inside the cabinet, what do we have? Up here at the top, we have our ECU, our electronic control unit. That is where the OptiFlow combustion management system software lives, up there at the top on the right-hand side. It drives the fan for modulation. Again, the fan's driven by an ECM, an electrically commutative motor is driving that. And it's also managing the gas. The gas flow is managed down here via a positive pressure gas valve. Since 2004, all of the high output Bosch tankless water heaters have used negative pressure gas valves. In this configuration, we've returned to a positive pressure gas valve. And we did that in order to allow the ECU via the OptiFlow software to independently adjust the gas flow from the airflow. And again, that's so that we can constantly tweak and make sure that the unit is hitting the highest possible combustion efficiency. The burner is down fired, 3 segments to that burner, and it fires over 6 different stages of firing, 6 different combinations. Primary heat exchanger is copper, and I know some people think, oh, copper, it's not durable, it's not durable. The copper is very, very durable, very durable. And the copper does a great job of energy transfer, very, very efficient on energy transfer, and also a very ductile metal. So as we have very cold water and very hot water, we still get the durability of that metal. Typically what destroys a copper heat exchanger is the formation of condensate inside of that combustion chamber. And with our combustion technology, we're not getting that. That's not going to happen. Also, for durability, built into the combustion chamber heat exchanger on the waterway. So as the water's moving through the copper tubing has what we call turbulators. And those turbulators are designed to ensure that we are disrupting the laminar flow of water through the unit so that we get even heating and we diminish or minimize scale buildup. Our condensing heat exchanger is stainless steel. Why is it stainless steel? Because it's very corrosive, because we are by design causing condensate in that section there. So it's 316L stainless steel, and it's a series of banked tubes. We'll look a little bit more at those banked tubes in a minute. So venting, all kinds of things you can do with the venting. There's so many options on venting for this product. Again, on 2 or 3 inch PVC, the range of materials is very, very broad. One thing that some people will look at here, they'll see this EWV, that is only for the intake side. The exhaust must be solid Schedule 40 on foam core PVC or other material. Again, vents 60 feet in, 60 feet out, maximum. That's the equivalency. And if you think about 60 feet, even if you throw 6 elbows into an exhaust, that 6 elbows eats up 30 feet. You still have 30 feet of straight pipe to get the exhaust out, and then another 60 feet equivalency to get the fresh air in. 12-inch clearance is pretty standard. 12 inches between the intake and the exhaust. It'd be 12 inches above ground or snow line. 12 inches from windows and doors when we are a twin tube or sealed combustion exhaust, 12 inches from windows and doors. And again, that's a minimum. More is better. If you can get more, that's better, but at least 12 inches there. Other types of terminations we can talk about, those bay type terminators, absolutely approved to use the bay type terminator. Snorkel is probably one of the most common ways we see these things terminated. We also have the concentric termination. That concentric termination allows for the single penetration, a pipe inside of a pipe to push the exhaust out and bring the fresh air in. We can go vertically. We can go vertically with a twin tube situation as well. 2 penetrations of the roof. If we're in the situation where we can't snorkel and we have to put our intake and our exhaust in the same plane, now we're going to drive ourselves up to 3 feet of separation between the intake and the exhaust. So just be aware of that if you're going to put them in the same plane, we do need 3 feet there. And all of that is to avoid cross-contamination. We're pulling something other than atmosphere back into the combustion process. That happens, that will lead to premature failure of the unit and poor performance. And here we're looking at that idea of the flexible polypropylene where we have a abandoned chimney and we're going to use it as a chase way. We can use that flexible polypropylene, and that's particularly helpful when we have a situation where that chimney might have an offset or maybe even a chase way that's offset or something like that. The flexible polypropylene allows us to get around there. If anyone's not familiar with the stuff, it's a little bit pricey, but it does some great stuff for us. One thing to be aware of, the flexible polypropylene is not approved in the lateral for anyone, but not by the manufacturer. It's not approved in the lateral. So you do need the rigid polypropylene in the lateral. Then it connects via a kit to the flexible to go into your vertical. And again, it can do an offset up to 45 degrees with that flexible polypropylene. Gas line sizing, big deal, man. We got to get enough fuel to these things, right? We have to get enough fuel. You see this chart here is our very conservative chart. This is one that only allows for a 1/2 inch pressure drop. That's all it allows for. So with this one, we're going to start with 3/4 inch. It's the smallest we're going to talk about is a 3/4 inch gas line. But I said you can use 1/2 inch. Yes, you can use 1/2 inch. And here we go. This 1/2 inch chart now allows for a 3 inch pressure drop, but says that you have to start with at least 8 inches of water column on natural gas to use that 1/2 inch gas line. And you can see on that 1/2 inch gas line, we can get out to 40 feet on 1/2 inch if we have that gas pressure to manage that for us. We're also approved for convenience on CSST. It's great stuff. Some guys love it, some guys hate it, but it always, when you're using that CSST, the corrugated stainless steel, make sure that you're observing the manufacturer's equivalent hydraulic diameter, so that compares it basically or normalizes it more or less to what black iron pipe would do. So that's what we want to use. Gas pressures that we're going to look at, propane 8 to 13 inches, natural gas 3.5 to 10.5. That's what we want to see gas pressure wise. Which Brings us to a quick look at the controls. These, again, touchscreen controls. There's a lot of information just on the display itself. It has a separate icon here for when it is firing. It gives you that little flame symbol. Gives you a rough idea of the percent of fire. This ring will go around the circumference here and show a rough percent of fire. If there's a problem with it, it will give an error code. That error code will be an alpha alpha or an alphanumeric code, and it will also give you a series of 3 or 4 different possible solutions to that error code, or things to look at on that error code right on the display of the unit without breaking out the manual or anything like that. It gives you some ideas where you can possibly correct that, whatever that issue is. Also, while it's operating, it lets you see a lot of the operational data, including your inlet water temperature. It'll let you see the flow rate, how fast is that water coming in to the unit. It lets you see your stack temperature via the NTC. You can see all of that information as the unit's running. Here's an actual photograph of one of the HMIs, those human machine interface. And again, English, Spanish, and French, probably the most common languages that they'll be set up for here in the US, but we do have those other 4 languages if we want. And the icons on that display, I think, are pretty easy for most people to understand. Down at the bottom, everybody knows that. It's a pretty standard icon. That's their power switch, or on or off. Moving clockwise around from there, we have the OK. OK, most people recognize as meaning enter, accept, select, go. A return arrow, that's escape, get out, return, go back, however we want to say it. And then the carets are going to allow us to scroll set point temperature. When we're inside of the diagnostics menu, it allows the scrolling through the menu. This is the control on the outdoor unit and the display for the outdoor unit. You can see it's not nearly as friendly as the indoor unit control. It gives just about all the same functionalities. It does not give solutions on error codes. It gives just the error code. But again, for the outdoor unit, if somebody wants that full functionality, you just get that optional touchscreen display. It's wired. That optional wired display looks like this. And connects via that 2-pin Molex. That's how we're going to connect that thing up and bring that inside. Give us all the same functionalities as the indoor unit. We also have the Wi-Fi capability, and the Wi-Fi app gives all the same controls that you have on the touchscreen, and actually a couple more. It gives a couple more things that it actually allows you to see the app that you don't necessarily see on HMI. So why do we do all of this? We want fast heat up. We want stable temperatures for the user. Modulation range brings a lot of that into play. And then the HMI giving the homeowner the ability to see what's happening with the unit. Down-fired, optimized by OptiFlow for combustion efficiency. Copper heat exchanger does a great job of heating water. And the stainless steel is going to allow us to extract all of our latent heat of vaporization. HMI helps the installer or the service person for setup or for service. Combustion management says, hey, we don't need that analyzer anymore, and then it'll set itself up for altitude or different fuel densities, all that kind of stuff. And then the Wi-Fi controls if we want those. Accessing inside of the cabinet, 2 screws at the bottom. The screws come off, the spring clips get released. The HMI is a quick disconnect here. It's not a Molex, it is just a quick disconnect plug here. And the unit will run with the cover off. It will run with the HMI disconnected. It will still run. So this truly is just a display for the ECU. We've got our fan, the ECU, that's where all the logic is. Down-fired, copper heat exchanger, stainless steel condensing heat exchanger. The ECU itself is held in place with just 2 screws. We lose a board, we know we're going to have to replace it. So, and it the house takes a lightning strike or a surge or something like that, and we lose a board. We want to be able to replace that as quickly as possible. In doing that is actually a universal board across the entire range of heaters, all 7 heaters. It's the same control replaces for all 7 units. And as you can see, it's all plugs on that control on ECU. It's all plugs. The only serviceable component, and hopefully that saves us from any surges, is there is this 4.5 amp fuse inside of the box. Aside from that, there's nothing that's serviceable on this printed circuitry. Modulating gas valve. So at the bottom, we actually have two gas valves. We have our safety solenoid, which shuts off all gas flow to the unit. Then we have our modulating solenoid that allows for the variable input. An artist rendering and cutaway of what it looks like. We have our three segments here. Top three segments of the burner. 6 passes through the combustion chamber, 2 layers of 3 passes each, copper tubing with all copper fins, transferring the heat energy from the flue gas, and then our banked tubes of stainless steel tubes down here at the bottom, allowing for extracting all that latent heat vaporization. Manifold itself segmented, so we have 3 valves that control each of the 3 segments. So segment 1 is valve 1, segment 2, and segment 3 by 3. Let's see the injectors, what it looks like in the actual flow of the fuel as it's coming in. The staging looks like this. Probably pretty obvious on the staging that stage 1 would in fact be segment 1. If you thought that, you'd be right. And if you thought that stage 2 would be segment 2, you'd also be right. But if you thought that stage 3 was segment 3, you'd be wrong. It's segment 1 and segment 2 together. Stage 4 is segment 3. Stage 5 is segments 1 and 3. And stage 6 is everything's lit all the way across. And that's how it's going to modulate. So it modulates independently within the stage and then across all the stages. And we can see how that actually looks here with the BTUs. So stage 1, segment 1, 3 injectors, 9,000 to 22,500 on natural gas. Stage 2, segment 2 actually could kick in at 16,400 input BTUs. What that does is gives us a very smooth transition from one stage of fire to the next stage of fire by having that overlap of the range of BTUs that each segment can put out. Downfired, Ceramat fiber diffuser over the burners gives us very, very even flame pattern. Conversion process, again, very simple. Fan this cap here to the left of it, 1, 2, 3, 4, number 25 screws. 4 screws come off, the cap comes off, behind there's a gasket. We no longer need the gasket. The gasket gets replaced by a gasket that has these brackets, and these brackets accept the orifices for the LP conversion. They are shipped separately in a separate bag. The bracket's the same, whether it's 160 or 199,000 BTUs. The orifices are different, whether it's 160 or 199,000 BTUs. So that slides in. You can see that it is witnessed so that we know that we have it aligned properly. It's all witnessed. Slides back in. The 4 number 25 torques get tightened down. Away we go. Next thing we have to do is go on to the control. Authenticate ourselves as a technician. So we're going to put in a passcode. That passcode is 1886. Scrolling through the menu, we go through authentication for technical settings. Scroll to 1, OK, 8, OK, 8, OK, and 6, OK. And that allows us to access those additional menus, including the menu P7, where we'll go in and change it from natural gas to propane gas. Press OK, and that converts it electronically. It also now gives us access to UC, which is combustion auto adjust. Combustion auto adjust is where the unit's going to go through a 9-step process to ensure the combustion efficiency. What it's basically doing is the process that a technician would do with a combustion analyzer. The electronics on the unit, the software on the unit are doing that for us using the ionization current, the flame sensor, to evaluate flame quality. It is 8 steps, and the only interaction from the contractor would be if there is not enough water flow, it will give the message open taps. That says, hey, there's not enough water flowing through the unit. We need more water flowing, and that will is the only interaction that the contractor in the field would have with this auto adjust process. That's it. And it is the most common reason why the combustion auto adjust fails, is that there's not enough water flow. There are a couple other ones if the gas type was wrong or the venting was out of specification or something like that, but that's the most common one. So if for whatever reason you don't trust our combustion auto adjust, you just don't trust it, it seems like too much witchcraft or something, you absolutely can use your analyzer, and we give you the table where you can manually force high fire and manually force low fire, and go through all of these steps manually and set it up with a combustion analyzer. If you want to do that, you can do that. 2 electrode sets. The electrode sets are the same across the entire range of products. We have the primary electrode set, which includes the igniters. So we have 2 igniters that arc across each other. They don't arc back to the burner or anything. They arc across the igniters. And then we have our flame sensor for segment 1 and segment 2. Over on the right-hand side, we have our flame sensor for segment 3, and these flame sensors are in series. Then this gives us a kind of a cutaway, a cross section of what exactly is happening inside of these heat exchangers. So we have our heat input, our burner pushing down from the top. All the while, the water is counterflowing. So the cold water enters the bottom left-hand side of the condensing heat exchanger. And the water it dumps into or empties into a bay or a header, however you want to think about it. And leaving that header are these 50 very small tubes. So this is our bank of tubes. These 50 tubes make up the first pass for water through the condensing portion of the heat exchanger. And a lot of times some people are looking at that and going, hey, small tubes, that means high pressure drop, but it doesn't. And why it doesn't is these 50 tubes, the aggregate or total cross-sectional area of these 50 tubes has more than 4 times the cross-sectional area of a single pass of the copper tubes. So what actually happens is the water moves through this section, its velocity goes way down. Flow rate, gallons per minute, is going to stay the same, but the velocity goes way down. So in doing that, what we're creating is a huge wetted surface area. So there's a lot of surface area in contact with the water and a lot of surface area in contact with the flue gases. So we're able to achieve that very high energy transfer through the condensing heat exchanger. And then to avoid the pressure loss of 180-degree bend to bring the water back on the next bank of 50 tubes, at the right-hand side, the header or the bank, or the bay, covers the first pass and the second pass. So the water pushes from these 50 tubes into that bay, gets picked up by these 50 tubes where it's brought from the right-hand side back to the left-hand side, second pass through the condensing heat exchanger. And then on the left-hand side, there's another bay, and this bay covers second pass and third pass. So again, we're not taking a 180-degree turn with it through copper, through stainless steel tubing. We are just dumping into a bay, gets picked up by another 50 tubes. Over to the other end, where it dumps into a bay and gets picked up by the copper and brought up to the combustion chamber heat exchanger, where we are actually bringing it up to temperature and keeping in mind, yeah, sometimes that's going to overshoot a little bit, but we have that active bypass that's going to ensure that we're going to hit set point very, very accurately and very, very quickly. The actual stainless steel, you can actually see out those tubes. Another one of our sensors, this NTC thermistor right here, is watching the temperature of the flue gases leaving the combustion chamber. The purpose of that is to actively monitor for scale buildup. If there's scale buildup in the combustion chamber, stack temperature will rise at this point, and we can monitor for that very actively. The cold water in, one pass, bay, second pass back, another bay, third pass, and then out and up to the combustion chamber. We also have the capability to do cascading. So if one heater can't get it done, we can let you put up to 24 of these in a cascade. We want to see that in a reverse return situation. So the pressure through each of the units is the same. We want to make sure that that's going to happen. We want to make sure that your gas line sizing and that your gas meter sizing is adequate for all the units. Then they work as a bank, and as they work as a bank, they actually have a lead lag function. So after the primary unit fires for 100 hours, it designates the next one as primary, and so on and so forth out through the entire 24 or up to 24 units. We can also do the idea of tank loading, and we can do that idea of tank loading using the controls for recirculation that are built in to the water heater itself. And this is the idea of creating a stored amount of hot water in a sealed tank where we don't have a stack loss or anything like that. So we have a very low standby loss. And what that allows for is high dump loads, and recharging that tank with basically what becomes a sidearm. Then after sales descaling, very simple. Again, we have those at the bottom. We have our service ports. So we're just going to take our transfer pump, washing machine connectors, and flush that thing out on an as needed basis. And again, we can check for that by looking at that stack temperature leaving the combustion chamber. Typically, we talk about white vinegar as our optimal solution for descaling, but there are certainly other options if you'd like. And with that, thank you so much. And I guess we'll open up for questions, Elaine.
Thank you very much, Chaz, for your presentation. Yes, we have some questions for you here. The first one is the Wi-Fi portal available now for 9,800?
The Wi-Fi is available, yes.
Okay, thank you. Can we use combustion air inside the house if enough cubic feet?
Yes, if there is enough, and we know what that is, it's 50 cubic feet per 1,000 BTUs. If the room is large enough, yes, you can pull room air. It's kind of a pet peeve of mine. Why I don't like it is because now on the outside of the house, now you significantly increase the required clearance to windows and doors. So that becomes sometimes a challenge then and having to manage that greater distance between windows and doors. And also for me, when people are talking about buying tankless water heaters, they're talking about buying tankless water heaters for comfort and energy efficiency. And when we're burning up air from inside of the house, where people are, heating, 4 or more months out of the year and cooling for 4 or more months out of the year, and we're burning up that air that they paid to condition, it really just drives down the efficiency of the thermal envelope of the house. It doesn't do anything to the effectiveness of the water heater, but the efficiency of the home actually goes down by doing that. So yes, we're approved to do it though. We can do it.
Thank you.